If you look at this problem, this is an important question. A1, A2, A3 are in AP and A6 is given in the problem as 2. We know one formula, AN is equal to A plus N minus 1 times D. So we can easily come to the conclusion that A plus 5D, that is equal to 2. I can come to this conclusion here. Now what is the value of D which maximizes this product is the question asked. So let's come to a conclusion like this. Let A1 is equal to A and common difference is equal to D. Let's say like this. Common difference is equal to D. So A1 into A4 into A5. Okay, that is equal to. Question is wanting to calculate the value of D. Question is interested in D, alright. So if the question is interested in D, I can write this implies A is equal to 2 minus 5D. I can replace like this because I don't want the value of A. Question is wanting only the value of D. So A1 into A4 into A5 can be written as A into A plus 3D, A plus 3D into A plus 4D, A plus 4D, A plus 4D. So I can write this as A can be written as 2 minus 5D and this is 2 minus 5D plus 3D plus 3D, 2 minus 5D plus 4D. Is it okay? 2 minus 5D plus 4D. So 2 minus 5D multiplied by 2 minus 2D multiplied by 2 minus D. It's not 2 minus D. So what do we get here now? We get, we'll multiply all the three. 2 2s are 4 minus 4D minus 10D minus 14D plus 10D square multiplied with 2 minus D. So we'll be left with 2 4s are 8 minus 4D minus 28D plus 14D square plus 20D square minus 10D cube. Is it okay? This is the expression. So we'll get like this, minus 10D cube plus 14D square plus 20D square can be written as 34D square plus 34D square minus 32D plus 8. This is the product here. This is the product. This is the product A1 into A4 into A5 in terms of only D. In terms of only D. So if I want to maximize this product, I'll call this a function of D. I'll call this a function of D. Say means let it be. Alright, say. I'll call this as a function of D. Now what are we supposed to do? Now from here onwards you have to do maxima minima concept of differentiation and you'll get the answer to the question. So what you do? Differentiate with respect to D. Differentiate with respect to D. What do we get? F dash of D. F dash of D. That is equal to minus 30D square plus 68D minus 32. After that put F dash of D is equal to 0. So what do we get? Minus 30D square plus 68D minus 32, that is equal to 0. So minus 15D square plus what we'll do? We'll divide by 2. Minus 15D square plus 34D minus of 16, that is equal to 0. Or I can say 15D square minus 34D plus 16, that is equal to 0. Take the sum and take the product. So it is minus 34. 15 into 16, 225, 240, 240. So which is nothing but minus 24 and minus 10 are the factors. What to do? Shortcut. Invert the sign of factors and divide by the coefficient of the highest degree term. So your D value can be either 3 8s 5s and 10 by 15, 2 by 3. There can be two possible D values. So what are we supposed to do now? You go for second order derivative. Differentiate with respect to D again. Differentiate with respect to D. Calculate the value of F double dash of D. What will be the answer that we get? Minus 60D plus 68. You first put the value of the first D, what you have got here. So 8 by 5. So the answer will be minus 60 multiplied by 8 by 5 plus 68. which is nothing but minus 96 plus 68. 68, 78, 88, 98. So the answer will be here minus 28. Calculate the value of f double dash of 2 by 3. So the answer will be minus 60 into 2 by 3 plus 68. So your answer here will be minus 40 plus 68, which is equal to 28. 28. You see that here this value is less than 0. Here value it is greater than 0. And you know from the concept of maxima minima that if the second order derivative results in the negative sign, it is understood that the d value is maximum at what? That point. So what is the maximum value of d at which the product becomes maximum is the question asked. So the value for this particular question is, what is it? 8 by 5 is the answer to the question.